An organisation's climate change strategy requires an understanding of their greenhouse gas emissions. Companies need to account for greenhouse gas or GHG emissions along their value chains and product portfolios to manage GHG related risks and opportunities. The GHG Protocol Standard categorises emissions as Scope 1, Scope 2 and Scope 3 emissions. As a simple demonstration of how to explain these three scopes and to visualize the GHG emission sources and calculations for a value chain, let's look at this value chain modeled in Solidatus. In this example, we see the value chain of a t-shirt printer. Their output is 3 types of t-shirts. And this is in the emission summary stage, or as we call it in Solidatus, a layer. In this model, we see the following layers in the value chain. Scope 1, reporting company. These emissions are caused by companies' direct activities taking place, which in this case is the printing of t-shirts and the admin of the organisation. This includes on-site energy usage like natural gas and fuel, refrigerants and emissions from combustion in owned or controlled boilers, as well as from their vehicles. Scope 1 emissions are those that are released during the industrial processes and on-site manufacturing. Scope 2, energy suppliers. These are indirect emissions from the off-site generation of purchased electricity, steam, heating and cooling consumed by the reporting company. Scope 3 emissions include all other indirect emissions that occur in the company's value chain and are divided into upstream and downstream emissions. Scope 3 upstream emissions encompass the indirect gas emissions within a company's value chain related to purchased or acquired goods and services and are generated from cradle to gate. Scope 3 downstream activities. Downstream emissions include the indirect greenhouse emissions within a company's value chain related to sold goods and services and are emitted after they leave the company's ownership or control. We can calculate carbon emissions as well. This view shows the total CO2 tonnes of emissions for each individual organisation or activity in the value chain. This is calculated by multiplying the properties tonnes CO2 per unit by units. These will be loaded in via an API from whatever carbon emissions calculation tool the reporting company uses, and then adds to that total anything that feeds into it via a transition. The cumulative figure eventually adds up to the CO2 emissions by product and by scope. The total emissions can be seen in either of the product t-shirt or the scope objects. This view takes the carbon emissions figures in for each attribute in the model and applies red, amber, green ratings using display rules queries based on the properties. Green is for attributes with total CO2 emissions of 500 tonnes or less. Amber is for emissions of 500 to 1500 tonnes. Red is for over 1500 tonnes. This is a simple example of how Solidatus enables analytics of model data to give a different user's perspective. Relevant regulations in Solidatus reference models can be linked to this lineage model. In this example, we can see the principal adverse sustainability impact statement layer, which is sourced from the SFDR. This shows a regulation related to emissions reporting. We can also see a data taxonomy, which in this case shows the definitions of each of the scopes. Terms of the reference model are linked via relationships to entities in the lineage model. To summarize, Solidatus can be used by organizations to discover, dynamically visualize, and sustainably govern their carbon emissions data environment. When an organization can trust and understand their data, they can make quicker and better informed decisions, save millions in inefficiencies, comply with regulations and legislation, thus avoiding fines, and discover new opportunities through quick visualized analysis. Solidatus gives you certainty that your decisions are driven by the right data.